here today. So today I wanted to talk about systemd services a little bit more, and then we're going to talk about some database stuff. So the database stuff should be pretty high level, just how to install those particular database services. We're going to look at MySQL and Postgres. We'll look at very basic, how do I add a user, how do I change a password for something, basic system administration work, but I don't think we'll get too much into doing query stuff. But we'll see how much time we have as we go along. So probably mentioned this already, systemd is really big now as the service manager on Linux and Unix systems. So systemd manages your services when they start, when they stop, and kind of manages a bunch of things surrounding them. Traditionally, there's been a bunch of different service managers throughout the history of Linux systems. The last one was I think it was called sysv, and that's, you'd see, if you see a init, like a initd at initd, things in that area, you'd probably be dealing with sysv init scripts. But there's a bunch of different other init managers that parse that kind of stuff too. But all of those were incredibly complex and just a very big pain to deal with. So the systemd people came along and decided they were going to completely redo how services are done, managed, controlled, logged. They are quickly taking over a lot of the Linux, kind of traditional Linux services that existed at one point. So when people say systemd, they might mean just the service manager, they might mean the log manager, they might mean the network manager, they might mean a whole bunch of things. The systemd project actually encompasses a significant portion of quote-unquote user space utilities for Linux. But today we're just going to look at services. Now unfortunately there's a lot of content about systemd. There's thousands and thousands of lines of code, hundreds of thousands probably, that just talk about the service manager, and what that also means is that there's thousands of lines of documentation that talk about the service manager, and there's all sorts of little rabbit holes we could get down into, but I want to just show briefly how we would look at services again, kind of figure out what a service is actually doing when we're starting it, when we're stopping it, when we're doing things like that, and how we would go about writing a basic service file, starting it, enabling it, disabling it, and kind of controlling its behavior. So one of the things you might run into is you're on a new system. Ubuntu, the 16.04 that we have right now, is full systemd, I guess, implementation. If you look at other distributions, I'm pretty sure our CentOS 7 that we have installed is not systemd yet. It's scheduled to be systemd. So when CentOS 8 comes out, if I understand correctly, and a number of other systems are systemd at this point. But let's say you are given a package or something, given some custom application, and you don't have a service for that application. You can kind of look at it, kind of see how it's run, and then build a custom systemd service for it, so it's automatically booted, automatically restarted if it dies, and just use systemd to actually manage that service. So that's kind of what we're going to look at today. So we'll just go ahead here and get started. So we'll start out with this, I guess. So how does systemd get so much power? So we're going to go through this entire process later, how Linux boots up and how all of these things are sort of managed and configured. It goes hand in hand with disk management and things like that. Basically, there's this file in boot. So inside this boot directory are all of the things that allow us to start up, basically. Boot. So we have our actual kernel binary that executes on the computer. And then we have something called an initrd, which sets up basic devices, kind of establishes the basic root file system that we see. We notice that we have files on the file system which aren't actually mapped to anything on a real disk. We have proc, we have sys, we have those type of things. Those are set up by initrd. Then we have our VM linas over here, which is actually our kernel binary. We'll go in here instead. But basically, here, cd boot grub. Grub is our bootloader, and our bootloader configures how things are loaded during boot. But what's worth noting is this one particular line right here, this Linux line right here. So this would specify our kernel, this would specify our RAM disk. Again, this is kind of off topic right now, but we'll get back to that later. But basically, when booting the kernel, it is going to determine which is the very first program that will be executed. So sometimes you'll see something like init equals bin init or something like that, but by default init, so that's the initial program that's going to be run when the kernel is booted, would just be set to sbin init. So if we go over and look at sbin init, so lsl sbin init, we can see that there's actually a symbolic link from sbin init to systemd. So if you're curious what init manager you're running, it's always probably going to be in either bin init or sbin init. Just remember that sbin stands for super user bin, basically. It's only binaries that can be run by root. But if you're curious what init manager you're running and you want to see if it's systemd and you lsl on it and it points to systemd, then it's pretty much guaranteed to be systemd. So we know that it started up and all of that. Remember, if we look at our process tree, you can see at the very beginning here of our process tree is sbin init, has PID1, and kind of implicitly owns all of these things. So PID1 has kind of special meaning. What that means is it owns all of the other processes. It can only be one PID1 and all of that. If you see all of this other stuff, just as a comment, that's all kind of internal kernel stuff that manages devices and lower level stuff, and we can kind of just ignore that for now. So, if you remember, we could say something like systemctl is the utility that we use to manage all of these service things. So we could say systemctl status SSH. And it would tell us if our SSH server is running. It would give us a couple log entries from SSH. You can see I just actually logged in here, so we got some interesting information there. And there's a bunch of different verbs that we can actually use. So again, we say systemctl, what we want to do, and then the service name. So let's say systemctl status cron d cron. So basically, cron is a service that will run certain commands at certain time intervals, something we're definitely going to talk about this semester. Again, status to see if it's running, see a couple log entries. Stop will stop the service, start will start it. Disable will stop it from starting on boot. Enable will start it starting on boot again, and so on and so forth. So that's kind of how we would look at system service files. But there's also, that's how we would interact with these services without actually doing anything. So the systemctl command actually has a number of different things to look at and edit service files as well. So we actually have a cat verb and an edit verb as well. ctl cat, let's just say ssh. So we can actually see right here the actual service file that instructs us, what systemd should actually do when it's starting and stopping, reloading, and enabling and disabling SSH. So SSH is actually relatively simple. We have a couple different sections in our service file. I'll refer you kind of to some documentation on what each of these mean, but basically we're going to have a unit, we're going to have a service, and we're going to have an install. at a very minimum, what we'd probably expect to see is we'd have a description, we'd have exec start, we'd have type, and we'd have wanted by. So, looking at this, it's interesting to see that we can configure when we want a particular service started. So we would say we want our SSH server started after network has been started. So there's a bunch of services that systemd, well, components I should say, that systemd manages that will build up to this network target, and once that network target has essentially finished loading, we will continue on and we'll load our SSH server. So we can actually list all of the different targets that we have on our system. If we're configuring things, we could say systemctl, lagging out here a little bit, list unit, actually lagging quite a bit here, units. And that would list all of the different things that systemd manages. So the systemd manages a whole bunch of different things, manages devices, manages disks, manages users, manages services, targets, and all of that. But for right now, we're looking at basic targets. So we say type equal targets. Target. So if we configure our service to depend on any of these different targets, they will only load after those targets have finished loading, or we can also configure our service to load before a certain target has been loaded. So the primary ones that we're going to actually look at are probably network target. So most of our services, at least our network services, don't want to start until we have network capabilities. We might also look at multi-user.target. So once our device has started up, once it has that login terminal that's prompting you for a credential, you'd probably that's multi-user target after those TTYs had been started and everything. Another one that we might wait until has finished or be dependent on is graphical.target. So after we've actually loaded a GUI interface. So that would never, if we configured our service to depend on graphical.target, that would never actually work on our server because we don't actually have a GUI, but it would work on our desktop because we do have a GUI. But there's a whole bunch of other different things. I mean, if we wanted to wait until all of our file systems were mounted, we could say localfs.target and things like that. So remember, to list all of the targets that you can configure, you just say systemctl list units type target. And I guess I should go back and I should say type service. So if we want to see all of the services that we have on our device, we can say again systemd list units type service, and that will list all of the services that we have available to us and running. So basically what these things mean here, there's a couple different columns. So load means that systemd has parsed this service file. It's available to be used. Active means if it's actually been started. And then there's the sub, I believe this stands for sub process. And this is a little bit interesting because services can be configured in different ways. Some services have processes that run continuously behind the scenes. Other services have processes that are conditionally started on a timer, started in a number of different ways actually. That makes things a little bit hard to keep track of and makes this column a bit confusing. I mean, this column would also says exited now, even though those services probably are running just fine. But it would also say exited if a service crashed or something like that. So let's just take this one right here, this AppArmor.service, and look at that. It's a systemctl status that, and even though it had said exited on that line, as long as we got this active green right here, we're pretty much good to go. So we were looking at systemctl cat sshd. again, we have our different sections here. So we talked about after, and then we had a target. So it will start after every service component device that was contained in that particular target had finished. Now, how do we determine which services were in that target? So we have down here this install wanted by. So we say wanted by this target, and it will append our, well, there's a bunch of things happening behind the scenes, but basically it'll append our service to a list that specifies which services are inside of this target. So let's say we had in our network.target network manager or something like that. So in our network manager configuration, it would say install wanted by equals network.target, because we need network manager up and running before we're able to do any networking kind of things. So this is how you would kind of build all of these dependencies. So again, what this means is saying wanted by equals multi-user.target is anything that says after multi-user.target has to wait for SSH to successfully be started before you can do anything. So typically speaking, most of your services that you see an SSH server, see a web server, kind of things like that. It would usually be after network target and wanted by multi-user.target. Again, basically what that's saying is, so multi-user.target, what you'd end up seeing is if SSH was being slow or something wasn't starting, if a web server wasn't starting, anything that kind of had this setup, is it wouldn't actually allow you to get a TTY until it was successfully started. But usually we don't have very many issues like that. So let's look at this a little bit more. So we have, this is one of our core directives right here is exec start. It just gives us the binary with an absolute path here. So we need the path to the actual binary. And then it gives any other options that we need to give to it. We have exec reload. So when we say systemd or systemctl reload, and then our service name, it will actually run this. So we're going to talk about this main PID in just a second here. That's a kind of a special little variable for systemd. Another important is restart on failure. So let's say our SSH server crashes. I believe the default systemd action is to restart, in fact, but this does tell us exactly what to do. So if it does die for some reason, it will automatically just be restarted. This is kind of interesting, very specific to SSH. So restart, prevent, exit status. So if for some reason SSH returns code 255 when it exits, systemd will not automatically restart it. So let's say your program has a particular error code that when it crashes, let's say something is corrupted inside of your database or something, and your service is starting, it's trying to connect to the database, but it realizes it's corrupted and it can't actually do anything. Instead of just spinning and restarting over and over and over and over and over again and not really doing anything productive, you could exit with a specific return code, and systemd would not try to start that service anymore, and it would just give up. And then we also have this type right here. So notify is actually kind of tricky. So what we're actually going to look at right now is simple and forking. So when people are actually developing programs, you can actually integrate systemd functionality directly into your program and kind of communicate back and forth with systemd. But that's kind of out of the scope of what we're trying to do right now. So we have cat that just displays our service file. Wow, I don't know what in the world is happening with the network today. Edit. So you can actually edit a service, and what this actually does is it installs an override on that service. So there is this etsy systemd system sshd.service.d. I suppose I should talk about this too. Well, before we do this, there's a couple different places that we can store these service files on our disk. I know there is cd etc systemd system is one of them. So our configuration file systemd system. But I also think there's user lib systemd system. Here, let's just go find where this is at. User lib systemd system. So it's also kind of a distribution dependent thing on the one distribution documentation that I was looking at right there. There was these system files in multiple places, but I can't seem to track them down right now. But this is the one location. System. So we have our one SSH service right here. SSH. Okay, so it's not user lib on Ubuntu. It's lib. So if we go over here to lib systemd system, this is where all of our services installed from the package manager would go. So we have a service, we just apt-get install SSH, its service is going to be put inside of this directory. But this isn't really intended to be modified by the system administrator, the user. Where you're supposed to put your service files, if you have them, is etc systemd system. So that's where I was before. So, okay, so when you go and let's say you wanted to edit a particular service, one thing that you need to keep in mind is when your packages get updated, these service files might be overwritten, might be changed, might be renamed, might be moved. So systemd actually ships with functionality to do these things called overrides to start with. Now, I haven't actually done much with the override system. What I read briefly on it, systemctl edit sshd, is basically it does make this ssh service.d directory in here, and I believe what you can do is override individual sections for SSH, or whatever services that you're working on. So you just say service, or unit, or whatever section you're working on, and then you list the directives below it that you want to override, and it would hopefully only override that one particular section. So it's kind of a way to deal with updating things. We're not going to look at making overrides right now because I just don't really know very much about that, but that's certainly functionality that exists. So we're just going to ignore that for right now. But what we are going to go ahead and do is make a simple service. So what I want to do is let's just make a little bash script that sends things to a TCP port or something, or cats some file somewhere. So I'll just go over to our root directory here. I just want to make sure it's a simple path and everything, that it works just fine. So I'm just going to say simple service.sh bin bash, and I'll just say basically our service. I'll show you a couple different ways that we can do this. We're going to do this a very simple way right now. We're going to have a single directive. Let's just say cat or we'll just say, actually, let's just say echo ID into netcat p 222, let's say 2000. And I'll just run that really quick to actually make sure I'm making sense. Localhost and we can see we got ID there. But it's also worth noting that it didn't restart, it didn't loop forever. One of the things that we could have done in there, and we'll come back and we'll do this in a little bit, is we could have had like a while loop around this command that would have ran that statement repeatedly over and over and over again. Again, all that's doing is it's getting, here's what we actually want to do. So we're running ID and we're piping the output into netcat listening on port 2000. So that's more what I wanted to do. And then what I did here was I just backgrounded it with Control-Z, BG to run it in the background, and then netcat to connect. And there we got what we actually wanted. But we want all that managed by the system. We don't want to have to log in, run something, do all of those kind of things. So what we're going to do is end up writing a service for this. So right now this would be considered a simple service. So let's, this is a little too complicated. Let's just look at SSH and see how that one was formulated. Systemd system. So we have our unit, we have our service, and we have our install. So we'll just say simple service dot service unit is it service, I think. And this syntax is a bit hard to remember offhand, and I'll definitely post some really good information about things. Install service, okay. So we would want to say description equals our simple service. We'd say after network.target. That's all we'd have for unit. We'd have exec start equals simple service.sh. And I think we will leave install blank right now. I don't think we actually need to put anything right there. So we're going to need to think about our reloading conditions right now. So when we want our service to be restarted, actually I need to say type equals simple too. So type simple just means there's one binary being, or one command being run. Things aren't going to be particularly complex. So remember when we were looking at our SSH server, we kind of had that tree of processes. It was a little bit hard to understand. It wasn't particularly hard to understand. It was relatively easy to understand. But we might need to configure certain things to control what would happen with systemd. But let's see if I did all of this correctly. So to actually have systemd look at the file system to reload everything, you need to say systemctl daemon reload. And that would go through. It would reparse all of the systemd files actually. Let's just say systemctl status simple service. And I didn't find it for some reason. No such file or directory. Let me just try and start it. Actually, I think I need to do .service.
I think you just misspelled service.
Ah, that would do it too. Service. And there we go. So we see we have loaded. It is loaded. We can see where it's actually at. But it's not actually started. So we would just say start. Our service is now started. Let's just look. Oh, lag, please. And doesn't look like it's actually running. started running. We have bash port 2000. Oh, we have on port 2000. Okay, yeah, it is running. No problem. So we'll just again netcat localhost 2000. Got that ID. So that ID is actually something that we're going to think about a little bit more in the future. Probably won't have time to do it today. We can see if we try and connect again. Again, that was a single, like, one thing we would do and then exit right away. But we can actually configure systemd to... Actually, let's look at status really quick. So, inactive dead. I think that's a little bit different than what we saw before, actually. No, it's still dead. Okay. So we could go back, we could edit it again, simple service, and then we could actually configure it to automatically restart. So we saw that in SSH, actually. Let's just look at SSH again. We had restart on failure. We can actually configure it to say restart equals always. So we'll always restart that service. Restart equals always. And that will always restart this as soon as it exits all the time, regardless of whether it was an error or not. So when you say reload, daemon reload, now we can start it up again. Now, if I know what's going on, every single time we would connect to well, apparently not every single time, but a number of times. So it's unfortunate that example doesn't work very well. But basically what's going to happen is going to respawn that script every single time. So again, remember what would happen is normally that script, it would execute that one command, and it would immediately exit. As soon as netcat had connected, it would take the result from ID, it would push it out on port 2000, and it would exit. So what we configured systemd to do right there is to restart to rerun that script every single time. But what's actually happening right now is I think we're running into some network challenges. And I think I was going a bit too fast there. One of the things that we could configure, see, we have a bunch of broken sockets right here. There's all of these on port 2000 that are just hanging out right now, and that breaks things. It would try and restart, and the socket would just fail, and it would just get in this fail loop, and it would just be all sorts of not fun. So we see it's just breaking here. I think at this point we'd be able to start it again. And it would continue functioning. Okay, so there we go. So the other way we could do all of this is without that automatic restart, we could actually configure the kind of looping mechanics inside of our script that we just wrote there. So we could cd over here, simple service.sh, and we could instead put this in like a while loop or something. So while, I think this is correct, true or do done. So I think they should evaluate to true. Let's just stop our service. So let's actually look at this quick. Let's look at stopping the service. TPN. See, we're listening on 2000 right now. Systemctl stop. Simple full service. You can see that died. Look at netstat. We have nothing listening on 2000 anymore. So by default, if you have a simple service with systemd, it will just automatically detect which is the process ID, and it will automatically send kill, I believe it's int. It will send sigint to that process when you say stop. Another thing that you can configure that we saw actually with SSH is what will actually be run when kill is sent. So there's kill mode. There's also exec kill, so you can specify a custom thing to run when you specify that stop. I think it's actually exec stop, never mind. Anyway, so let's go. Let's go back here, look at simple service. So we put that in the while loop. Let's just make sure that works. I don't think one's going to work. While true. I don't know if true is a thing we can do in bash. Okay, there we go. So true is a thing we can do in bash. I'll just ZBG that again and C, do it a bunch of times. So now our application is controlling that restart. So if we had an application that controlled restart and things like that, we could actually go back to etc systemd system and look at simple service, and we could turn off this restart always. And that wouldn't be required anymore because our application controls that. So that would be a very basic systemd service. So we also might want to do wanted by equals multi-user.target. That just kind of sets up the dependencies and makes sure and ensures that anything that does depend on multi-user.target has this service running. So one of the things, again, that systemd does is it manages kind of this hierarchy of services. Let's say you have a service that depends on a database. Let's say you're running some sort of web application that needs database to be started. You might want to put the database in network.target. You might want to put the or after network.target. So the database would be completely started. Put it in wanted by multi-user.target. Put the web server in after multi-user.target and wanted by another particular target. So everything would be loaded in the correct order and you wouldn't end up having any errors. So we could actually go and we could turn this service on, enable it. I think it actually might be enabled by default, but we'll think about that here really quick. Simple service. So it enables it just like that. So if we go and we reboot, what we're going to hope to see is that this service is running, and it's going to work, and everything's going to be nice. So we'll see if that actually happens. Give this a couple seconds to reboot here. And let's see what we have. Sudo I. And of course, it didn't work at all. Enabled. Target. I might have. I didn't do daemon reload, which might have messed things up. Die. Yep, there we go. Left off my eye there. So it didn't actually do any. It probably would have actually. Let's see if when I would have done reload, I might have just started a little bit too soon there. Systemctl. Damn it. I always get the spelling mixed up. Reload. Alright, so it didn't actually tell me what was going on there, but I believe, let's try this again, that it was just because I left off this I right here. It should have said multi-user.target. Let's just look at SSH here really quick. It's multi-user.target, so good thing I checked that again. And because of that parse error, I didn't know what to do. So in order, okay, so I should back up a little bit here. So in order for enable and disable to work, you need to have this install section. So again, what this wanted by does is add our service to this list of things that need to be run when this target is executed. We actually, so we see we have a multi-user.target.wants. So multi-user, let's enable this again. Enable. So multi-user. Yes, see here's the direct. I actually made this directory before when I messed up, but this is the target that's actually executed by the system. So this is what we want. So in here we have all the services that will be started once we hit that multi-user.target. So we see we had our SSH service right here, and we had our simple service right here that we just wrote. So now everything should be working fine, I think, now that we had the right multi-user.target. So again, go ahead and reboot. Give it a few seconds here to do all of that. I guess we're only going to get systemd done today. Stat LTPN, and we're listening on 2000. Status simple service, active running, shows us our processes right here, bash running netcat right like that, as expected. So that's how we would write a very simple service. I think that's definitely something worth knowing how to do. Like you're going to be encountered, you're going to have custom binaries that you need to run as a service. You're going to want it to definitely be able to restart when your system reboots and things like that. So definitely worth knowing. So I'm going to finish off with some of the other ridiculous capabilities of systemd. So there's just pages and pages of stuff, and I don't even really know where to start with all of this. Basically, if you remember this, NNC localhost 2000. Remember, we're running ID, and as our service, it's running as root right now. So if we don't specify anything else, our services will run as root with systemd. So that's definitely not what we want to happen. I think I'll actually probably come back to this and talk a little bit more about systemd during our next class. But we can actually configure which user we want things to run as, where we want things to run, and actually configure a bunch of security options to do with those things. But anyway, so easy security hardening, basically. Read only. Certain capabilities you can remove. You can only allow everything inside of that area to do certain things. But anyway, so socket-based activation and path-based activation are kind of cool. Hard to describe what exactly is going on there. Basically, what socket-based activation does is systemd manages your TCP sockets. So let's say you have a web server listening on port 80. You could configure systemd to listen on port 80. And what you could configure it to do is to spawn a new process for each connection that was inbound. But at the same time, it wouldn't actually spawn any processes until somebody was connecting to that particular port. So that would be perhaps a way to save resources on your server. So until somebody actually connects to that port, and until somebody requests the web page or something, it wouldn't actually start your web server processes until that time. So you could also have a path-based activation. So one thing we should actually talk about this a little bit is FIFOs on Linux and Unix sockets. Actually, basically, it's like a TCP socket, but actually it's actually a file. So with path-based activation, it would be very similar to socket-based activation. Device-based activation would be like when you attach a USB device, a particular service might be started, things like that. So we have a whole bunch of different things that systemd actually manages. So it can manage sockets, devices, mount points, swap space, timers. So timers are kind of cool too, things like that. This is a very, very good piece of documentation definitely going to post this on D2L. And then templates are cool too. We'll just talk again about it later. So that's all I have for System D today. So I hopefully you found something interesting there. Again, definitely worth knowing because you're probably going to have custom services, custom binaries, things that are broken that you need to fix, and things like that. So any questions about System D, about Lab 3 or 4, about anything in this class, feel free to stick around after and we can